Hello dear friends, welcome to session on turbo machines on centrifugal pumps and compressors, module 5, prescribed by Vishweshwarya Technological University, Belgavi. This is Dr. Rudresh from Mechanical Engineering, Government Engineering College, Krishrajpete. So in this session, I would like to talk on a maximum suction lift in a centrifugal pump, a net positive suction head, cavitations in centrifugal pumps, priming in centrifugal pump. So let us think about a maximum suction lift. When a centrifugal pump is concerned, there are two important the portions that we have to concentrate. One is the suction side, the other one is the delivery side. Delivery side is not so important, but the suction side is very, very important because the suction side is the side, or the suction portion is the portion which defines the overall performance of a respective centrifugal pump. If you want to define the manometric head, or if you want to define how much amount of the lift that the system has took place, right, that the system is working against, right, so that will be decided by the suction side. Therefore the suction side is very, very important for a centrifugal pump. Now you are seeing in the figure a centrifugal impeller. The impeller is available. At the same time, the delivery pipe is there, and the suction pipe is also available. And there is a sum which is consisting of a liquid whose pressure has to be raised, and we have a free surface. We have the section 1 which seems to be the center line, and the section 2 which seems to be the free surface of water. Vs is nothing but, V suffix s is nothing but, it is the velocity through the suction side, that is through the suction pipe. Consider a section pipe, consider a centrifugal pump that lifts the water from a sum which is shown in the figure. The free surface of the water is at a distance of hs from the axis of the pump. We have considered the axis of the pump here. Let V1 is equal to the suction side, the inlet section side, let it be V1, and the outlet side, outlet delivery side, let it be V2 or V suffix D with usual notations that we are discussing right now. Hs is equal to suction lift or the height. Hs is nothing but it is the suction lift or the height. HL is equal to, H suffix L is equal to head loss due to friction in a suction pipe. Here we are considering only the suction pipe into considerations, but we are not considering the delivery into considerations, because it is the suction lift which is the result of a suction at the particular side of a centrifugal pump. Therefore, we have to concentrate more on the suction side of a centrifugal pump. Now in this case, consider section 1 at the axis of the pump and section 2 at the free surface of the liquid. When you see the two sections, so we know that in case of a centrifugal pump, the total energy at the section 1 will be different, and the total energy at the section 2 will be different, because the section 2 is always the free surface of water, and the section 1 is always the center line of the center axis of the respective centrifugal pump. Applying the Bernoulli's equation between the two sections, assuming the section 2, that means the free surface of water, as the datum, I can write the expression P1 by rho g plus V1 square by 2g plus Z1 plus HL is equal to P2 by rho g plus V2 square by 2g plus Z2. That means this is the standard Bernoulli's equation for a real fluid. Z2 is equal to 0 because of datum, that is the free surface, we are assuming it as a datum. Therefore, P2 by rho g, it's a delivery. So when you see this P2 by rho g is nothing but it is the pressure head at the free surface of the water. It is nothing but an atmospheric pressure head. V2 is equal to 0 because the velocity at the free surface of the liquid, the velocity is always 0. Therefore, P1 by rho g plus V1 square by 2g plus Z1 plus HL is equal to PA by rho g. What is Z1? That is the vertical distance from the center of the axis to the free surface of the water. This can be called as the suction lift, or it can be called as a suction head. Yes or no? H1 is equal to Hs, that is equal to suction lift. Therefore, if you see this expression, V2 is equal to 0 because therefore P1 by rho g plus V1 square by 2g plus Z1 plus HL, that is equal to PA by rho g. Solve for P1 by rho g in this expression. PA by rho g minus V1 square by 2g minus Z1 minus HL. For maximum suction lift, I can say this: the pressure at the inlet of the pump should not be less than the vapor pressure of the liquid. This is one of the technical principle one has to know with respect to suction side of a centrifugal pump. That means the pressure at the inlet of the pump should not be less than the vapor pressure of that liquid in order to have a maximum suction lift. Right? Therefore, considering the pressure at the inlet of the pump equal to the vapor pressure of the liquid, we have, let us consider P1 is equal to P vapor. Right? P suffix vap, that is equal to vapor pressure of the liquid. Therefore, P vap by rho g is equal to PA by rho g minus of V1 square by 2g plus Z1 plus HL. PA by rho G is equal to PV by rho G plus V1 square by 2G plus Z1 plus HL if you solve for P atmospheric in this case. So therefore PA by rho G is equal to PV by rho G plus V1 square by 2G plus Z1 plus HL. But in this case we are considering Z1 as HL. HS, sorry. HA is equal to, say for P vap by rho G is nothing but, say for example, HV is nothing but what? It is the vapor head. Vapor head, right? So HA is nothing but, it is the atmospheric pressure head. Vapor pressure head. H suffix V is nothing but vapor pressure head. Plus V1 square by 2G, the velocity head across the suction pipe. HS is the maximum suction lift. HL is the head loss due to the friction in a suction pipe. Therefore, for maximum suction lift, HS is equal to HA minus HV minus V1 square by 2G minus HL. This is the standard expression for the maximum suction lift. Therefore, the suction lift must be less than the vapor pressure head of the liquid at the inlet of the pump. Otherwise, there is a possibility of cavitation. I am discussing about a cavitation in the last slide in this particular session itself. But in order to avoid that particular cavitation, the pressure at the inlet of the respective centrifugal pump must be equal to or greater than the respective vapor pressure of the liquid. Thereby, we can avoid the concept of a cavitation, right? So, this is one of the important the thing which we have to keep in mind while discussing about the maximum suction lift in case of a centrifugal pump. The next one is the net positive suction head. So, as centrifugal pump is concerned, there are different heads which are available in the system. It may be a suction head, it may be a delivery head, it may be a manometric head, and at the same time, we have a suction head at the respective inlet of the centrifugal pump. The net positive suction head. What is this net positive suction head? This net positive suction head is very commonly used in pump industries. It is denoted as NPSH. It is the net head available at the suction side of the centrifugal pump. Net head available at the suction side of the centrifugal pump means what? So what is one more head which is available? We have one more, a vapor head. Vapor pressure head is also available at the respective suction side of the centrifugal pump. Therefore, you cannot say that the whatever the suction that is creating at that particular point is nothing but the suction head. No. In addition to suction head, there is a one more head called the vapor pressure head is also available at the suction side of the centrifugal pump. So to calculate the net positive suction head, it is always positive in nature because we are lifting the water. That means the total amount of the water that has been lifted, right? That should be greater when compared with any other suction head which is available at the suction side. Therefore, the net positive suction head is defined as the absolute pressure head at the inlet to the pump minus the vapor pressure head plus the velocity head. These are all some of the important things that we have to concentrate on the net positive suction head. So if that is the case, if PF by rho G is equal to suction head at the inlet of the pump, PV by rho G is the vapor head at the suction side of the pump, Vs square by 2G is the velocity head at the suction side of the pump, then the net positive suction head NPS is equal to PS by rho G minus PV by rho G plus Vs square by 2G. So we have the absolute pressure at the inlet. P1 by rho G is equal to PA by rho G minus P1 square by 2G minus HS minus HL. Considering the suction lift, maximum suction lift into consideration. Therefore, NPS, if you write this NPS and you substitute these values, PA by rho G minus V1 square by 2G minus HS minus HL minus PV by rho G plus V1 square by 2G. So, therefore, that is equal to PA by rho G minus PV divided by rho G minus HS minus HL, right? So, if we consider this entire system as NPSH, right? So, therefore, this NPSH is always given by NPSH is equal to HA minus HV minus HS minus HL. So this particular suction head is which is available as seems to be the net positive suction head at the respective the suction side of the centrifugal pump. So this equation is very important when you define the respective suction head as well as the net positive suction head as well as the vapor pressure head also, because whenever the vapor pressure is considered for the respective situation, the net positive suction head has to be calculated. These are all some of the important things that we can expect from the respective system. So even in the previous sections we have discussed about the different concept, that means the net positive suction head. But considering the vapor pressure head and the atmospheric pressure head, the total suction head and the total head loss due to the friction through the suction pipe, when you consider all these things, right, then what is the net positive suction head? NPSH is always given by HA minus HV minus HS minus HL. This is one of the important situation. This is one of the important equation one has to know before designing any of the respective centrifugal pump. So when we discuss this, the value of the required NPSH is given by the pump manufacturer. So you can ask one question. So net positive suction head, is it possible to determine? Yes, experimentally it can be determinable. But Once when you're designing a system, that pump designer has to highlight what is the NPSH of that particular pump. Therefore, to avoid the cavitation problem in case of a centrifugal pump, especially at the suction side, the available net positive suction head should be greater than the required net positive suction head. This is very important concept. Therefore, the net positive suction head plays a very important role in the performance of a centrifugal pump. So one important the concept and operation which we can take which we can consider it as an effects, right? So the cavitation concept. So the precautions and the effects of cavitation. So what is the effect of this particular cavitation, or what is the actual concept of this particular cavitation is very important. When you see this cavitation, right? So what is the actual concept of this cavitation? So very important concept. When you see this cavitation, so we know that whenever the pressure of the liquid, say for example, we have got an hydraulic system. In an hydraulic system, whenever the pressure of the liquid will falls below its vapor pressure, the formation of vapor bubbles is going to occur in the system. When these vapor bubbles has been carried to a respective different zones where the pressures will be keeps on varying in nature. When these vapor bubbles has been accompanied with the highest pressure inside the hydraulic system, there is a blasting of these vapor bubbles is going to occur. Due to this blasting of vapor bubbles, the surfaces which is coming in contact with this particular type of the bubbles, they will get a pitted and they will get some type of the cavities. It is always called, that action is always called as a pitting action, right? This particular form of effects will create more volume of noise, and at the same time there will be the cavities which will be produced on the respective inner surface of the respective pump, right? So that particular concept is always called as a cavitation concept, right? A cavitation is nothing but it's an effect, right? So where the pressure of the water may fall below its vapor pressure, by that time there will be a formation of vapor bubbles, right? So due to sudden blast of these vapor bubbles at a pressure at a particular position where the pressure is very high, right, and they will create some cavities on the inner surface of the water. This particular concept is called cavitation concept. How to take the precautions? So again, this particular cavitation, the pressure of the flowing fluid in any part of the hydraulic system should not be allowed to fall below its vapor pressure. That is the one thing. The next one is, for the material is concerned, the special cavitation resistant materials such as aluminium, bronze and stainless steel can be used for hydraulic systems. What are the effects of cavitations, right? The metallic surfaces and the metallic surfaces are damaged and the cavities will be produced on the respective surfaces. Due to sudden collapse of vapor bubbles, there will be a considerable noise and the vibrations can be expected. The efficiency of the turbo machines decreases due to this particular cavitation. This is one of the important effect of cavitation, right? And what are the important the machines that you can expect for the cavitation process? The hydraulic machines subjected to cavitation process are only the reaction type of machines like reaction turbines and the centrifugal pumps, because both are reaction type of turbo machines. So the reactions type of turbo machines are always susceptible for the respective effects of cavitation. The last one is the priming in a centrifugal pump. So why the priming is required? One important concept is a priming of a centrifugal pump. Why the priming is required for a particular centrifugal pump? One of the important concepts. Say for example, what is the meaning of a priming? A priming of a centrifugal pump is defined as an operation in which the suction pipe, the casing of the pump and the delivery pipe up to the delivery valve is completely filled with water or is completely filled with a liquid by an external source whose pressure has to be raised, right, before starting the pump. Because suppose if this particular action has not been taking place, the manometric head or the rise in pressure head within the impeller, within the suction side will exactly, which is not equal to the respective manometric head of the respective system. Then it is not possible to lift the water from the respective system. Technically, what do you mean by saying a priming? Why the priming is required? The work done by an impeller per unit weight of the liquid per second is known as the head imparted by the respective impeller onto the liquid. So what is the head generated by the impeller? U2 VW2 by G. You just see this equation. This equation is independent of the density of the liquid. When you are considering the priming in a centrifugal pump, centrifugal machines can handle the different types of the liquids, can handle the different types of the fluids whose densities are keeps on varying in nature. We have got a water which has got a high density liquid. We have got an air. Here has got a low density liquid, low density fluid. If that kind of situation occurs, then how to tackle this particular type of priming? So when you see this particular equation, density plays a very important role for priming a centrifugal pump. The density of a liquid plays a very important role. This means that when the pump is running in air, the head generated is in terms of meters of air. If it is primed with water, the head generated is same meters of water. But as the density of the air is very low, the generated head of air in terms of equivalent meters of water head is almost negligible. And hence the water may not be sucked from the pump. Sufficient amount of the manometric head, sufficient amount of the pressure head will not be developed so as to equal to the respective manometric head and more. In order to avoid this difficulty, priming is required. This priming concept is one of the important, a primary concept to the respective centrifugal pump in order to effectively improve the respective performance, in order to effectively improve the respective working performance of a centrifugal pump. This concept is very, very important. Therefore, the priming is also one of the important concepts. Therefore, so in this particular session, so we discussed about what is the maximum suction lift and what is the next positive suction rate, right? And what is meant by cavitation and what are the remedies that we have to consider for the cavitation? What are the effects of cavitation? At the same time, so how we can define the respective priming in a centrifugal pump? Why the priming is required for this particular centrifugal pump? So these are all some of the concepts which we have discussed in this section. So in the next sessions, we will be bringing you the different the concepts related to centrifugal pumps. Thank you.